As a developer, we've all come across bugs in our code or somebody else's code. And it's always frustrating and it's difficult, and we always need to fix it as quickly as possible. One of the worst things that can happen is our bug leads to a security vulnerability in the code base we're working in. So how do you quickly resolve that before it's exploited by hackers or people who have bad intentions? Blitzy is an autonomous AI development tool. It can help enterprise teams build software, add features, and solve security vulnerabilities in days, not in months. Now, the way that works is Blitzy has an infinite code context. It reads in all of your code, and then when it's making changes, it has the context of your entire code base. It's not just working on one library or one module, it's looking at the holistic view of your entire code base when it's making those changes. So if you're thinking about a security vulnerability that got a lot of attention in the last few years, probably the first one that comes to mind is the Log4J bug from December 2021. Now, Log4J is an open source logging platform. It's used ubiquitously in Java applications. Now, what happened was in 2013, a bug was added, and it wasn't actually found until 2021 when it was found by a security engineer at Alibaba. That bug became known as Log4Shell, and before you knew it, Log4J, which was popular in the Java community, suddenly became a household name around the world. So what was going on? Basically, the vulnerability is Log4j allowed requests to just arbitrary LDAP and JNDI servers. And so when logging a string, it could open up a web page, and that web page could execute malicious code on the server. So if you had a string that was logged, the attacker could load that malicious code hosted on that public URL. Even if the execution of the data was blocked, some of the attackers could still pull things like environmental variables, which might give you access to other services inside the cloud environment. This was a big deal. The initial severity rating was 10 out of 10, and it had the potential to execute across millions of devices. AWS, Cloudflare, iCloud, thousands and thousands of organizations were affected. Some even estimate that 93% of enterprise cloud environments were affected by this vulnerability. Ars Technica called it arguably the most severe vulnerability ever, and it was quoted in the Washington Post that it bordered on the apocalyptic. All of a sudden, the whole world knows about Log4j. The team was originally notified at the end of November, and there were quickly several patches made. This first patch was made on November 29th, no longer formatted the lookups in messages. That turned out not to be enough. They ended up just restricting LDAP access by the JNDI, and then they started to limit the JNDI later in this end of December. And these were the major pull requests that were merged in to resolve the Log4Shell issue. Now, as I mentioned, this was all over the internet. It was on national news. There was so much advice for developers on what to do if they use Log4j. But what if you were on the development team? What would you do? How would you go about solving that? So what we wanted to do was to see if Blitzy could solve the issue that occurred inside the Log4j vulnerability. The Blitzy platform reads in source code, analyzes it, and creates an initial tech spec. So here I am in Blitzy, and I am bringing in release 2.4.1, which happened in May of 2021. So it was vulnerable to Log4Shell. When I bring in this code, Blitzy is going to analyze it and look at the code and create a technical specifications document. Again, let's zoom down here and not up over in here. The technical specification document is a detailed document that describes how the application works. Once you're happy with the technical specification document that's been read in by Blitzy, if you're not, you can edit it. You can then begin building. And in this case, we want to fix a security vulnerability. When fixing a security vulnerability, it needs a prompt. What is the issue we've identified and how do we want to address it? So here's the prompt that we used to tell Blitzy how to fix the Log4j bug. What we said is, while you're searching the internet and looking for ways to solve it, don't use the CVE. Don't use any page that has the CVE that describes how it was fixed. We want you to solve this on your own using other resources. So you can't use any of the CVE databases, any of the GitHub commits referencing that. So what happened? JNDI injection vulnerability on Log4J from 2.0 beta to 2.14.1. This is a critical severity, and then we can't trigger these lookups, and we can't execute any remote Java objects. So we can only make those changes in the Log4j core, in the lookup mechanism. We're telling Blitzy where the bug is, what it can work on, but not to go too far outside of that scope to fix other things. Blitzy might be a little aggressive and say, hey, we could fix these other things over here. We're focusing just on that security vulnerability. We want to do minimally invasive patches. We want to disable or remove the JNDI lookup logic and put in a failsafe and inert defaults. So we want to patch it, and then, how can we control it? And then how are we going to test it? And then at the end, the minimal change clause. So like, we're only modifying JNDI, don't do anything else. We give that prompt to Blitzy, and Blitzy begins processing. After about 8 minutes, Blitzy comes up with a future technical specification. And at the beginning, it lists through all of the things it needs to be done. This took about 10 minutes. So it's going to eliminate the ability for attackers to trigger these JNDI lookups. Here's the technical interpretation, and here's the implementation. This implementation is just about exactly what was done to resolve the Log4Shell bug in the Log4j app. Here's how we're going to implement it. Here's the scope boundaries. Here are the security validations. And then this is the existing technical specification. This was run, and you can see that there's a PR open. Let's look at that. It took Blitzy about 5 hours and 20 minutes to create this PR, and we can see that there were 11 commits and 8 files changed. At the very beginning, there's a security markdown file, and there were a bunch of files. There's a bunch added to it. So what was added to the security MD? This was already present. Everything in green was added. So we've got a JNDI vulnerability mitigation, and it walks through everything that was done. There was removal of JNDI. The lookup interpolator has been modified to skip JNDI registrations and reject all the patterns. The patterns were blocked. We have fail safes and defense in depth. Migration guidance. So here's what we need to do to migrate it. Here are the properties. Here's the verification that things were fixed. The other thing I like looking at when Blitzy's completed work is the project guide. And if we look at this project guide, it says that this is 100% complete. So this project has been hardened against JNDI injection, addressing issues similar to that CVE. And so here are all the things that were done. It's showing that the work is 100% complete, and the JNDI lookup was removed. We've hardened stuff, we've secured things, we've controlled, and we've removed the test for the JNDI lookups. We've done testing to verify that it works. It compiles, it builds, and here are all the details. You can see what was done: 25% on testing, 25% on the lookup removal, pattern level blocking, and configuration controls. Here's the security work that was done. Here's the setup to show that it was all completed. Risk assessment is, hey, we've gotten rid of all of the things that were causing the Log4Shell issue. The risk level is now minimal instead of that 10 out of 10. So this is really neat that we said, hey, we know where there's a security vulnerability. Blitzy, here's what we're seeing. Here's our understanding of it. Can you go through and solve it? And within just a few hours, Blitzy has created code that solves the Log4j issue that came about in 2021. Pretty exciting, pretty phenomenal to look at that it got solved in just about 5 or 6 hours of the AI doing the work. Stay tuned to this channel for a lot more videos on how Blitzy can improve the way your development teams are building code, fixing code, and resolving vulnerabilities in their code. Thanks for watching.